Hi everyone, just wanted to take a minute to talk a little bit about kind of some word problems involving quadratic functions. But to start it off, I think it's important to make sure we're aware of the different forms. So really quickly, let me just write them down. So we have f of x is equal to a times x minus h squared plus k. For vertex form, standard form is f of x is equal to a squared plus ax squared plus bx plus c. And your factored form is f of x is equal to a times x minus p times x minus q. Now, really, what do all these give us? Right, this is very good for vertex. And what does the vertex give us? Well, that is going to be your max or your min. All right, so if you're ever looking for a problem with max or min, you need the vertex. The other two, you can get the vertex, maybe not as nice, right? Maybe not as nice. Maybe not as easy, right? You have to do the negative b over 2a. You have to find the average of these two. Is not as easy as just me looking going hk, right? So your vertex, right, being hk. This one, what's its big claim to fame? Well, number one, it's kind of the most easy to, I guess, just write if you just had somewhere from somewhere, right? It's in the standard form of a polynomial. So this right here, this is your y-intercept. And that's really helpful because that tends to be your initial or starting value or your initial height or something like that. Right, so it tends to be your initial value. And then finally, you have your factored form, our newest form. What's its big claim to fame? Well, it gives you, the x-intercepts of, p0, q0, right? So it gives you the x-intercepts. Now, what are those helpful for? Well, one of them is usually going to be kind of like the end, so to speak, right where it lands. Like if you're, throwing a ball, where's the ball land? Well, it lands at the x-intercept where it hits the ground, where something lands. So these each kind of have their own little piece of information that is helpful to you in terms of what it would look like if you're looking at the graph. Additionally, sometimes when you're writing things, it's easiest to start with this, like for area in particular, right? Like this is one side length and that's the other side length and stuff like that. But anyway, so let's take a look at some word problems just to make sure we're on the same page with these. So when we're looking at these, a very common thing for you to look at is going to be area, really, right? Because area is going to be x squared. So we looked at area in the past when we were just looking at ax squared. But now we can kind of look at, some different pieces of information. So what do we have here? So a company is offering rectangular pool sizes with dimensions as shown of 2x, x, and 4. If she wants a 15-foot wide pool with a deck, how many square feet will she need to have available in her yard? Right, so essentially, what do we need to figure out here? We need to write a quadratic function to represent the area of the pool deck, and we need the area of the pool and the deck. So let's set everything up based on this picture. Right, so you can almost think of it as length times width. So if you were to take a look at this, right, 2x squared, x plus 8, x plus 8. Now, where's that coming from, right? It's 4 all the way around, so this is 4, this is 4. So that's why you have the plus 8. And that kind of makes sense, right? In terms of it being factored, if you made it, negative 8 would be a factor, right? You plug in negative 8, you get a 0 with. That kind of be like that's essentially what happens if you kind of look at a parabola. This is essentially over here, one of them is what happens if you have 0 width, and the other side is what happens if you have 0 length. Now, from this point, you could potentially solve it from here, depending on what you're trying to do. In this case, it eventually wants us to figure out how many square feet she needs to have available if she wants a 15-foot wide pool with a deck. So then you would have to try and figure that information out. So if we need to find the area of it with 15, you're just going to plug it in. Now, there's no reason why you couldn't have plugged it in here, right? You could have plugged it in here, saved the squaring, but you then would have had to multiply potentially two bigger numbers, I guess. Where you plug it in does not make a difference. but ultimately this is a very common situation to be in. All right. So suppose, let's take a look at this one. Suppose that the length of the pool is 3 times the width. How does that change the function, right? So before it was 2x. So now if we were to set this up, right, now we're going to end up setting it up like this. We're still going to have the x plus 8, right? Because this is still the, 4 here and 4 here. But now instead of having 2x plus 8, we're going to have 3x plus 8, right? So now if we were to plug in the 15, that is going to make a slight difference, right? Obviously, you have a bigger number here. You're going to have a bigger area that you need to account for. Okay. Now, a very common situation that you can come across is something called vertical motion. Vertical motion is represented by a parabola. It really comes kind of from like gravity, and a lot of motion things are going to be dealing with it. Right? It's kind of the model you use for like throwing basically anything up in the air or rockets or anything like that. It has this equation, negative 16t squared. So right off the bat, it looks like this, where VO is the initial velocity, and then HO is going to be H naught, or HO, H naught. Usually you'd call it H naught, and V naught is the initial height, right? That makes sense, right? If this is the initial height, that's the, the y-intercept, the initial height. And this value right here is essentially how fast it's going. Now, what does this kind of look like here? Well, it looks like this sort of problem. You jump off the platform with an initial velocity of 16 feet per second. What's the quadratic function that represents the height h of the diver after t seconds? We know it's 30 feet tall, so we can essentially just plug that in. Negative 16t squared. Remember, my initial velocity is 16t, and I'm starting up at 30. Okay. Now, how many feet above will it be at the highest point? Now, again, this is essentially saying what pieces of information do I need to know? I need the max, so that means I need the vertex, right? So what you would have to do is you could do one of two things. You could either hope you find it in vertex form, which it's not, so that doesn't help us. You can do negative b over 2a, or alternatively, you could factor it and then just find the average of the intercepts. It's your choice, whatever works best for you. If you particularly like negative b over 2a, use negative b over 2a. All right. But ultimately, when you take a look at it, right, you just plug in all the information. Now you would need to find the maximum value. So they're using the negative b over 2a. You get 1/2. Plug in 1/2. You get 34. All right. So you got to be careful, though. The question itself is asking how far above the platform. So if the max height is 34, the platform's 30 feet. In total, it's only 4 feet above, right? So do be careful with that. So find the maximum height if we're now at a 20-foot platform with an initial velocity of 8 feet per second. So if we take a look at this, negative 16t squared, right? My initial velocity, that's this number, 8 t plus 20. All right, so that's my function. Now we do have to essentially, if we want to deal with this, to find the max height above the water. So be careful. This is now asking for max height above the water. I need to do negative b over 2a. Again, alternatively, you could have factored a 4 out of this and then potentially factored. I don't know if that would make anything easier, but you could do that. So negative 8 over 2 times negative 16. So I have negative 8 over negative 32, which is 1/4. I'm going to plug that in now to get the maximum height. Uh, 1/4 squared plus 8 times 1/4 plus 20. All right, what's this end up being? This is negative 16. 1/4 squared is 1 over 16, so over 16. Plus 8 times 1/4 is 2. All right, so this is negative 1 plus 2 plus 20 ends up being 21. So he only ends up 21 feet above the water, which is really means he's only doing a little bit of a dive over. But ultimately, that should be relatively straightforward. All right, let's do one more for good measure. Paul hits a baseball straight up in the air. The baseball is hit with an initial velocity of 70 feet per second when it is 3.5 feet off of the ground. What model is going to represent this? So again, just a straight up plug in. Oops, not 0, x. Oh, I'm sorry, I made a mistake. I don't want to use it. I should not have been writing x. I should have done f of t. That's my own mistake. So right. So make sure you're writing f of t. Negative 16t squared plus 70t plus 3.5. And there you go. There you have it, right? So you should make sure that you're doing f of t. I wonder if that's still there. Nope. So make sure you're doing f of t. But ultimately, those are some nice word problems that you can kind of look at. Again, the form really is dependent on what piece of information you have and what is most beneficial to you. So let me know if you have any questions, and have a great day.